Yeah, hi everyone, this is Ravi Prakash and welcome to Geometry 13, right? So in this video, we'll discuss about the midpoint theorem, proportionality theorem, and its 2 to 3 beautiful applications, right? So let's discuss it. Now, midpoint theorem. Midpoint. What is midpoint theorem? See, it will come from similarity only, right? Nothing else as such. Midpoint theorem. But we need to understand midpoint theorem. See, this theorem states that this is a triangle ABC, and D is the midpoint, right? D is the midpoint of AB. So from D, if I draw a line parallel to the third side, from D, if I start drawing a line parallel to the third side, right? This is the line I'm drawing. So just we're drawing line parallel to BC here. So it will go and meet AC at the midpoint only. So it will meet AC at the midpoint only, right? So first point is what? So first point of midpoint theorem is what? E is the midpoint. E is the midpoint of triangle ABC. Sorry, of the side AC. E is the midpoint of AC. And second point, this length DE is half of that parallel side which I have drawn, right? So this D is drawn parallel to BC. So DE is what? DE is half of BC. So two statements of midpoint theorem, right? First one and second one. Remember these two, right? When you draw a parallel line, which is parallel to the third side, it will meet the opposite side at the midpoint only. First point, right? And the second point, if that length line is drawn, right, which is parallel to the third side of triangle or any side of triangle, right, that length of line will be half of the triangle, right? This again proves a similarity. Similarity, right? Because these lines are parallel. Okay, these lines are parallel. That means triangles are similar. So when triangles are similar, what is the ratio of sides? The ratio of sides is what? It is 1:2. Since it is a midpoint, what is the ratio of sides? 1:2. That's why DE is to BC also 1:2. Right? This is midpoint theorem. Okay. Now proportionality theorem. Now proportionality theorem is, see, if I draw two parallel lines here, and I draw from a single point, it doesn't matter how many transversal I draw, right? Let's draw this is one transversal, this is one transversal, this is one transversal, right? All cutting these two parallel lines. Okay, all cutting these two parallel lines. So from a single point, if I draw all this transversal, the ratio will be same, right? This ratio, this is A and this is B. This is C and this is D. This is E and this is F. So it's like A by B is equal to C by D is equal to E by F, right? This is proportionality theorem. Okay. So if this from a single point, it doesn't matter how many transversal I draw, cutting the parallel lines, the ratio will be same. The ratio will be same, right? A by B equal to C by D equal to E by F, right? Now let's do question. This is a question here. Triangle ABC. Now this AM is the perpendicular. Okay. T is the midpoint of BM. I'm marking it. BT and BTM are equal. This joins the midpoint of AC. Let's say N is the midpoint of AC. I'm marking here. AN and NC are equal. Okay. Now BC is given as 16 and AM is given as 12. So find the length of TN. Find the length of TN. Right. It's a good question to start with. Very good question. Okay. Again, just pause this video. Try for 5 minutes. Right. Honestly, you do it. Okay. I'll be solving now. Okay. So see. Now, this is diagram here. The BC is given as 16. Okay, fine. This BC is 16. Okay. And this AM is given as 12. That's okay. Now from T to N, T is the midpoint of BM, N is the midpoint of AC, right? Now you see here, again, this concept will come. I have to find the length of a line which is neither horizontal nor vertical. So I told you in previous videos what to do. I should simply apply Pythagoras theorem, right? When a line is tilted, it is neither horizontal nor vertical. Simply drop a vertical line, drop a horizontal line. This is 90 degree. Get this length. This length will be root under a square plus b square. So simple a concept, but it has got a magnificent use, right? So similarly, Tn is a line which you need to find the length of, drop a perpendicular, right? So it's 90 degree, right? First thing you should do is this one, 90 degree, drop a perpendicular, right? Now you see in diagram what extra I have, right? So you can see it now. If you observe it, you see a triangle AMC. In triangle AMC, you see N is the midpoint. In triangle AMC, N is the midpoint, and a line is drawn, which is, this is 90 degree, this is 90 degree, right? A line is drawn. Since both are 90 degree, that means these two are parallel. These two are parallel, right? So it becomes the application of what? Midpoint theorem. Since both are 90, so these two are parallel. If these two are parallel, what will happen? What is midpoint theorem? If this is 12, this will be 6. This will be 6. This NS, mark it S. So this NS will be equal to 6. As well as S will be the midpoint of MC, right? S is the midpoint of MC, right? Now connect quickly with Pythagoras theorem. Sorry, midpoint theorem. What is midpoint theorem? In triangle AMC, so in a triangle, N is the midpoint. So midpoint, a line parallel to the third side is drawn. Parallel to the third side is drawn, right? So what is the first point? It will meet the opposite side at the midpoint. That means S is the midpoint of MC. What is second point? Its length is half of that parallel side. So 12 half is what? 6. 12 is given. This is 6, right? Why it is parallel? Because I drew a perpendicular. Right? So I drew a perpendicular from here to here. And this is 90. So this is also 90. So that's why these two are parallel. Why I drew a perpendicular? To apply Pythagoras theorem. Why to apply Pythagoras theorem? Whenever a line is tilted, right, it is neither horizontal nor vertical, simply drop a horizontal line, drop a vertical line, 90 degree, get this by Pythagoras theorem, right? So very important concept, right? So you got S is the midpoint of MC, right? So now what do you need to find? In this triangle is 90 degree, right? So what do you need to find? TS. You need to find TS now. Okay. So to see how much is TS now? See, this is S is the midpoint. This is X, this is X. And since T is the midpoint of BM, this is Y, this is Y. Right? So it's like 2X plus 2Y is equal to 16. Therefore, X plus Y is equal to 8. Therefore, TS is equal to 8. So it means what? It means that this TS is equal to 8. This NS is equal to 6. This is 6, this is 8, this is 90 degree. So what is Tn? So Tn is 10, right? Pythagoras theorem, put under 6 square plus 8 square. So Tn becomes 10. Right, so very good question it is. Fine. Okay. Move to next question. Next question. Draw this diagram quickly, and then what you can do, pause this video for 5 minutes, then try it. These are absolutely super questions, right? Which I'm discussing here. Concept building questions. These are not random questions, right? So I've picked this question at this place to explain the perfect concept, right? You try this, make a mistake, then you will do it, understand more, right? Now ABC is a triangle here. Now N is the midpoint of BC. I'm marking it. N is the midpoint of BC, and this P is the midpoint of AN. P is the midpoint of N. I'm marking it. P is the midpoint of AN, right? Let this point be AQ. This point be Q, right? So first question here, AQ is to QC. What is the ratio? Second question here. Second question, if area of triangle, ABC is equal to 120, then what is the area of triangle APQ? Right. So very good question again. So we'll solve it now and we'll learn concept through it. Right. Good concept. See, this is a diagram here, right? Now I need to find a ratio of AQ. I need to find a ratio of AQ is to QC. So AQ is to QC. I need to find a ratio. Okay. So how to do it here? See, I know N is the midpoint of BC. Fine. P is the midpoint of AN. And this part should be equal, right? But I can't in this triangle. Look at triangle ANC. Look at triangle ANC. I can't connect this triangle APQ is a triangle, and now NPQC is a quadrilateral. So triangle to triangle I am not able to connect, right? So what I should do here is this AQ I am not able to connect with QC, right? So in terms of ratio, right? So what I should do here, I should in trying to connect with QC, this if N is a midpoint here, right? What I can do, draw a parallel line, which is parallel to BQ. So BQ is parallel to, let's say, NR. Okay, so if BQ is parallel to NR, okay, now see what will happen. Very interesting concept this is, right? So what will happen if BQ is parallel to NR now? So in this case, look at triangle BQC now. Look at triangle BQC. So in triangle BQC, N is the midpoint of BC, and a line NR is drawn parallel to the third side. So according to midpoint theorem, it will meet at the midpoint of the opposite side, right? That means R is the midpoint of QC. That means R is the midpoint of QC, right? So we have drawn in triangle BQC, we have drawn NR is parallel to BQ. That implies that R is the midpoint of QC. Because NR is what? NR is a line, we have drawn a line NR which is parallel to BQ, and N is the midpoint of BC in triangle BQC. So this NR will be, this line will meet at the midpoint of the opposite side. So R is the midpoint of QC as well. Second statement, NR will be half of BQ. NR will be half of BQ, but that is not needed here, right? We're trying to connect AQs to QC. So QR and RC are equal, right? Fine. I need to connect with AQ. I need to connect AQ with QR. Now I have to connect AQ with QR. See, you can look at this triangle ANR. Look at this triangle ANR now. In triangle in ANR, see this BQ is parallel to NR. BQ is parallel to NR. Therefore, automatically PQ is also parallel to NR. Right? That means if PQ is parallel to NR and P is the midpoint of AN. Okay. So if P is the midpoint of AN, so from a midpoint, a line parallel to third side is drawn. From midpoint in triangle ANC, a line midpoint from point P, that is midpoint of N, a line parallel to the third side is drawn, parallel to NR, right? So PQ is parallel to NR is drawn, right? And P is the midpoint. So by midpoint theorem, it will also meet at the midpoint of the opposite side. That means Q is the midpoint of AR. That means Q is the midpoint of AR. Okay, that means this AQ and QR are also equal. That means AQ is equal to QR is equal to RC. Fine. So what is the ratio here? So ratio becomes what? This is trisected at Q and R. AC is trisected at Q and R, right? So what is AQ? If all are 1, 1, 1. So if this all three part is equal, so what is AQ is to QC? Answer is what? 1 is to 2. Right? This is 1 is to 2. 1 is to 2. So very good concept, right? Very good concept. Okay, now next question, second one. First one we did, second one. Now second one, if area of triangle ABC is 120. If area of triangle ABC is 120, then find the area of triangle APQ. Right? See, you can see here directly that I need to connect from triangle to triangle. Right? Triangle to triangle. Triangle APQ. I'm trying to find triangle APQ. Now it is part of triangle ANC. It is part of triangle ANC, right? What is the area of triangle ANC? So area of triangle ABC is 120. So area of triangle ANC will be how much? 60. Because N is the midpoint, what is the ratio? Ratio is 1 is to 1. So 120 becomes 60 and 60 both sides. Right? So area is 60 and 60. So triangle ANC, what is the area? Area is 60. So if the triangle area ANC is 60, so I can just see the diagram here. So this P is the midpoint. So that means what is this ratio? 1:1, right? This ratio is 1:1. So this ratio is, basically write this. This ratio is 1:1. 1:1. Okay. And this ratio is what? 1:2. So I can directly write triangle AN, triangle APQ is what fraction of triangle ANC? So due to this P, it is 1/2. It is 1/2. And due to this Q, it is 1/3. 1/3, right? That means 1/6 of triangle ANC, which is 60. So 1/6 of 60, that is 10. So 10 is the answer. Triangle APQ area is 10. So again, a beautiful application of this triangle ratio division method by area, which we did, right? The area of triangle by ratio method, right? So very good question. Kindly revise it. I hope you got it right. So very good concepts. Okay, one more question we'll discuss. One more question. See, these two lines are parallel. These two lines are parallel. Okay. Very carefully making diagram here. 6. Okay, now see. This is 12. This is 16. This is 14. This is 10. Okay. We need to find the area of the shaded region. We need to find the area of shaded region. Right? It's given that, now let's mark the sides A, B, C, D, E, F. It's given that AB is to BC is nothing but 7:5. It is given. Okay. And also given that BE is parallel to DC. BE is parallel to DC. This is also given, right? Pause this video for 5 minutes at least. Try this question by heart, right? So very good question, very good concept. Just try it. Okay. So I'll be solving now. Okay, this is 90 degree given here. I'll be solving now. I hope you have tried it. Okay, tried honestly. Now see. Since this is 12, this DC is 12 given. Okay. Now this AC is 16 given. This is 90 degree. So I can get this AD. I can get what is AD now? So AD has to be 20. AD has to be 20. Right. Why 20? Because Pythagoras theorem, na? 12, 16. So AD has to be 20 now. Right. So see, I can get, now I have in this triangle, look at this triangle AED. In triangle AED, I have the sides as 14, 10 and 20. So sides are 14, 10 and 20 known here, right? So I can get the area of triangle AED. I can get the area of triangle AED. So area of triangle AED can be known by that formula, root under S into S minus A into S minus B into S minus C, right? We can know the area of triangle. But in this case, if I have to calculate the area of triangle AED, area of triangle FED, which is required. So I can write area of triangle FED. Area of triangle FED is. Now I should know this ratio, right? I should know this ratio. In which ratio F divides AD, right? I can directly find it. So in which ratio F divides AD. So see, for that, you see these two lines are parallel. These two lines are parallel. Right? So in a parallel line, we discussed this is what? This is proportionality theorem, right? From a single point, if transversal are drawn, this is a transversal, at AC is a transversal, And what is this ratio? This ratio is what? This ratio is 7:5. So from a single point, it doesn't matter how many transversal are drawn, it will cut a parallel line in the same ratio. That means AC is also a transversal to both these parallel lines, and AD is also a transversal to both these parallel lines, right? So if this ratio is 7:5, this ratio also becomes 7:5. Such a good concept, right? This ratio is 7:5, this also becomes 7:5, right? A beautiful application of proportionality theorem, right? We always keep this theorem, reading these theorems in books and all, right? How to apply it. This is very good concept, right? So what is area of triangle FED now? Area of triangle FED is what? I can write it is 5/12 of triangle AED. Again by ratio division, right? By ratio division of area. This is 7, this is 5. So what is area of triangle FED, the shaded part, to the whole part, right? So 7, so that's 5/12. 5/12 of triangle AED. And what is area of triangle AED? So 5/12 of root under S into S minus A. What is S here? So S for triangle AED. 14 plus 10 plus 20/2. That is how much? 24, 22. So 22 into S minus A. 22 minus 14, that is 8. S minus B. 22 minus 10, that is 12. S minus C. 22 minus 20, that is 2. Okay, if it is fine here. 22, 8, 12 and 2. Yeah, it is fine. So it becomes how much here? See, 8 into, you can write here like this. 8 into 2, 16. 16 root 4 will come. 4 and 2, 8 will come. So see, how many 2's are here basically? You simply calculate how many 2's are here inside. So 1 2 is here. 1, then 2 cube. 1 plus 3, 4, plus 2, 6 and 1, 7. So there are 7 2's here, right? So basically I can write like this. Okay, 2 raised to 7 into 11 into 3. So something like this, right? So this 2 raised to 6 will come out as 2 cube. So I can write, okay, 5/12, right? Or I can write here on here itself. What is the final answer? Come like 5/12. 5/12 of. Now 2 raised to 6 will come out as 2 cube. Inside 2 will be left. So 2 into 11 into 3 will be 66. So root 66, right? So it is 8 something. So it becomes 5 into 8, 40/12. What is 40/12? 8/3. Okay, 8/3. So 8/3 root 66. That is the answer. That is the answer. Okay. 8/3 root 66. 66 is the answer. So very good question, very good concept. I discussed about the concepts of midpoint theorem and proportionality theorem and its beautiful application, how to apply in question, right? This you don't get in any books and all, right? Directly you see a theorem, its application, right? All those minute theorems in geometry, its application. So minutely we're discussing geometry. You'll not get a single problem, difficulty in geometry, right? Every question you can do in exam, like CAT, NMAT, IFT, ZAT, any exam you pick, right? Okay, yeah, thank you so much. We'll study next video further.